And it is the database and the test is on Moodle. Did that before class started. More and more companies, it's only 50 points, so you'll see it's smaller than 602 and 6022. More and more companies are concerning themselves with the health of its workforce and its impact on key organizational outcomes. Productivity, job satisfaction. You know, I've thought about it. I know I've asked you this before. Thinking about wellness is becoming such a big aspect in the workplace. Do you think it's a company's prerogative? I mean, should they even be caring about their health of their workforce? Do you think it's something that, you know, man, it's about bottom line? Do you think they should be carrying all these wellness, corporate programs, memberships for gyms, testing on blood pressure and cigarette smoking? What do you guys think about all that?
I'm yay.
It can save them on insurance costs, productivity, and time off.
Okay.
Work. So even if
is there empirical evidence that? I mean, I've heard that many times, but is there true empirical
I've heard
evidence?
Anecdotally, I haven't actually looked at the studies. I mean, I remember looking at our lit reviews for 602 and 22.
Yeah.
Some of the articles I found there said people are more productive when they exercise.
Do you buy it?
Yeah.
Why?
Because I feel better when I'm exercising.
So is it the endorphins? I mean, is it a catecholamine release?
Well, I mean, you just look at general health, like people who are healthy and eat well and exercise are, you know, less likely to experience chronic disease, you know, or make like heart attacks, things like that too. So, I mean, in that sense, I buy it. And plus, my girlfriend works for a corporate wellness company, so I have to.
Right.
I have to really sell it. So.
Right. Would you guys, if you had a company, would you institute some type of wellness facet, even though it may cost you a little bit?
Yeah.
Would you try to have some type of gym membership or testing for BMI, blood pressure, et cetera, some of the vitals? You would?
I would.
Why?
I think it's a worthy investment. I mean, it will pay off in the future. It's a long-term investment.
Okay.
Or maybe even short-term in some cases. I think a lot of the evidence is just surfacing because this has just become something we're implementing.
So look at this. This is kind of an advertisement that I got from the web. L&T, Health and Fitness, can help your organization lower healthcare costs. Almost very much what Zach was saying. Improve morale, maximize performance through health and fitness management services that show employees you care about their well-being. So it sounds like a PR push, but still, as an award-winning national producer of workplace fitness and wellness programs for 25 years, L&T is a one-stop shop for organizations' fitness and wellness. So there's even, you know, these major corporations that are gearing as consultants to start wellness programs. And just a quick Google search, analysis of worksite fit program, 92, association between work performance, physical activity, cardiorespiratory fitness in 2004. I had my first taste of research on this in 1989. I was a brand new student at CSPP, taking a class called Work Motivation, and Kim Leahy, Mark Rosenthal, and I were in a group of three. Kim Leahy's now at Center of Creative Leadership, and we were interested in fitness in the workplace. All three of us liked to exercise, and we actually did a project on it. Didn't find a lot of journal articles, right? There weren't journal articles like these, and so now you can see there's much more interest in it. So you will access the database to answer the following research questions based on a controlled randomized trial of 140 employees from a local biotech company who are randomly assigned as follows. Control, experimental group. Simple two-group design. 71 in the control, 69 experimental. Sample sizes are fairly even, so I deliberately made it fairly even. Where the experimental group participates in on-site wellness program, they get a private trainer, regular lab testing, weight management. Your first task is to describe the following three variables, each which is a composite score based on Likert items. So you're going to see this all dovetails with the homework you've had. You're going to look at nutrition, overall satisfaction with diet and nutrition, physical health and weight, satisfaction with weight and physical health, and satisfaction with sleep. Sleep is getting a lot of research the last few years. A lot of research on sleep. There was even another article the other day, a research about just being compromised 1 hour of sleep. We know it impacts kids, but even adults it can. Why were you saying? You were saying.
That's what we run our grant for.
Oh, okay.
Sleep and the relationship between people's schedules.
Yeah, in fact, we use this thing, the major inventory is called the Pittsburgh Sleep Questionnaire.
Yeah.
Well, I've analyzed that for my variable back at Penn. I've got a couple articles. One article that's been published, and now one that's submitted, sleep hygiene being one of the variables. And I've been doing
a class on the clinical side this summer.
Yeah, I've been doing that with a lot of nursing researchers who've been looking at sleep. Why do you think sleep is getting so much attention in the last few years?
People are sacrificing it.
Yeah.
I mean, is it really gotten worse than it is? I mean,
I don't think it's gotten worse.
Well, because I'm doing stuff on work-life balance, and what they're finding is that because people can't have so much responsibility at work and at home to sort of fill in that time, they're taking away from sleep. So, because if you, like someone like Chad who has a family and a full-time school and part-time job, the only really place you can take that extra time out of is from sleep. So I think more.
And there's consequences.
Yeah, and there's consequences for it. But yeah, that's usually the first place people take away from.
I mean, it's interesting, Zach. I would have never thought it's just an hour or less. If you sleep, usually you're used to 8 hours, you get 7 hours. Usually you sleep 7, you get 6. I used to think an hour wouldn't be that big of a deal. But they've actually shown, like high school performance, some of the kids, especially because a lot of kids are going to sleep with their smartphones, and they're responding to texts at 2 a.m. and 3 a.m. that parents don't even know. They're responding to texts through the night, and thus interrupting the delta sleep, the 90 minutes for REM. So they may get a cumulative 6 or 7 hours, but they're not getting that needed
No, and the
REM.
adolescents need more sleep because
Mhm.
the brain's still
Mm-hmm.
growing. And adolescents are more disposed to being night people than day people because of that brain growth that they're experiencing. And we make them go to school at like 7 a.m.
Yeah.
Right, right.
There's a lot of,
I would fall asleep in my third period class. Like, I just think no matter how, what time, like how much sleep I got, I would always fall asleep like right at 11 o'clock because I had to be at class, school at 8 a.m.
it's a drag.
Yeah.
Right.
It's a drag when you don't get enough sleep, and it has some long-term and short-term consequences. But in America especially, we compromise because the best never rest, sleep when I'm
You got to work hard, look at the yacht. I mean, just the person and how many hours she puts in. She talked about one who's now getting rid of the telecommuting.
Yeah.
So what you're going to do is describe the distributional properties as you did with one of your early homeworks, outliers, supplement with graphics, as well. Now you are well aware how to test for multivariate skew, kurtosis, normality using DiCarlo's macro, so please do so. It might also be helpful to use certain plots, error bars, box plots, to compare the groups. When I say might almost also be helpful, it equals please do it. I just thought when I realized, I thought I'd make it clearer, so please do it.
Not quite so passive aggressive.
Yeah. Yeah. Number 2, you decide to see how well the 3 variables reviewed in the prior question predict organizational stress, as rated by the employee. Important note, the higher the score, the lower the stress. Okay, you guys got it? Usually we think about it, so 1 is very high stress, 7 is very low, so keep that in mind. Conduct multiple regression, review the results, write up a professional APA-style synopsis of the study with tables, but I don't need 30,000 tables. Be economical in which tables will best tell the story. Make sure to review the assumptions, residuals on X and Y, leverage, influence, collinearity. So what would be your ultimate recommendation to the wellness team in regards to the variable criterion relationship? What would be your ultimate recommendation? And then, just the third question. So you only have 3, everybody. And this will dovetail with your final homework you've had to be handed in next week. Your final research question involves comparing 2 intervention arms, control versus experimental. So you don't have to worry about a Tukey or post hoc. I just did 2 groups. And you're going to have 3 outcomes. Conduct a one-way Manova, interpret the results and assumptions, univariate and multivariate. What's your recommendation of management in regards to the efficacy or impact of the wellness program on these outcomes? Again, here, now that you have 2 groups and 3 outcomes, you may want to get creative on some of the charts. Maybe showing a bar chart of the means, right? So people can get a visual examination of the difference in the means between groups. So that's it, everybody. 3 little questions. Not for 3 weeks, I guess. So you have plenty of time on this. Any questions on the take-home?
And then do we have an in-class midterm that same day?
Yes.
Okay.
Yes. The in-class exam is on the 25th. You got it. And it'll be covering touches, discriminant function analysis. Even though I may start on the 11th, I may be able to get going on factorial analysis of variance. So I may start lecturing on Chapter 8. But we'll see where we are. Because again, you were short-shrifted 1 week, which, as I told you on the first day of class, there's a slight chance you won't be able to do your in-class SEM presentation. You'll still do the analysis, But that used to be one class, and now unfortunately, because we have one less Monday, instead of 15 weeks, we have 14 weeks of scheduling. We may not have time for the in-class presentation, and we'll see how we go with it. Discriminant function analysis, or
Ask a question, just throw it out there. Would it be possible, since some people in here are not morning people, to kind of take the test proctored at our leisure and have an extra lecture? I don't know if that would be.
no,
something-
that'd be kind. That could get too screwed. I don't want to. Some people do it, some people don't. I want it all done in one time, especially because I don't want the test to be compromised.
Okay.
So, well, yeah, I know what you're saying, but what we may do is, you see, the presentation would have been the 13th. We'll have to see how far along we get in class.
Okay.
We'll have to see, because I'd love to have you do the presentation, but we still might be able to.
Okay.
I'm hoping. But you'll definitely do the structure equation modeling analysis. Okay, guys, so far, all your DVs. So far, all your DVs have been of what? At least level of measurement. Whether regression, Manova, t-tests, correlations, nominal ordinal interval ratio, minimally. Yeah, at least ordinal, right? At least ordinal, and hopefully what? Interval or ratio. But,
What if we have nominal?
yeah, what if the nominal is the outcome? Now, do you recall the last lecture in regression, the technique that's used for nominal outcomes? Does anybody remember that from 6022? That we're going to spend a bit of time in this class. Logistic regression. And we're going to talk about that soon. So here, what if you have for a group is the DV? Right? What if you have nominal level outcome, everybody? Then you got discriminant analysis. Which means group will be the DV. This will be different, right? You're going to find the continuous level predictors and the group as the DV. Two primary purposes. It's used for descriptive and classification. You're going to find two major purposes associated with descriptive, discriminant analysis, and for classification. So what if you have two groups, everybody, and three discriminating variables? Here's one of my fancy schmancy graphics.
I had the hardest time with my graphs on the last homework. They kept stacking on top of each other.
Oh, did they?
Yeah, it was a mess.
Oh, that's...
What, in a word?
Yeah.
Let's say, everybody, we have organizational stress, organizational commitment, and organization involvement, and I have two groups. Could be males, females, executives versus staff. So now, instead of seeing, God bless you, if the two groups differ on these three outcomes, notice that these are X's now. Do you see that? What if we want to say now, do these groups, right, do these three discriminating variables, how well do they predict or discriminate among a grouping outcome? So it's kind of like a reverse Manova, where your goal is to assess which of these variables does the best job at group separation. So it's a little bit different, isn't it? You're going to find there's a lot of analogs to Manova, but you're just reversing the Y's and the X's. So here, what you're basically saying, so instead of Y is a function of x1, x2, for Manova, let's just do a vector of y1, y2, y3 is a function of x. We have Remember now X, right? Or grouping, I will say the grouping, group variable is a function of what, everybody? X1, X2, and a linear combination thereof. So do you see we're reversing it, everybody? We're basically reversing it for discriminant function analysis. So there's many types of examples where you want to use it. And just to show you where the interface is, everybody, what we will be doing is analyze. Do you see this option called classify? This would be your first time in any of the stats class you've used this option. Discriminant. So here do you see where it says grouping variable? And there's the independence. So it's the reverse of the Manova, isn't it? Now the grouping variable will serve as the outcome. Often DFA is used as a kind of a follow-up to Manova. Often it could be used as a follow-up to Manova or exploratory tool. I generally, I don't want to say I want to kind of coffee off this. I generally don't see an a priori hypothesis, right? A priori means what? It comes before or after? Before. I usually don't see an a priori hypothesis associated with discriminant function analysis. There's nothing wrong if there is. But usually the interest is which variables best leads to between group differences. So everybody, do you think HR would have information on who has stayed in the company and who has left in the past year? Right? What might be some good predictors of that?
Your relationship with a direct supervisor.
Okay, tell me why, okay?
Theoretically, people quit bosses, they don't quit jobs.
Okay. Is that true?
I believe so, yeah.
Is that true?
I haven't gotten into all the empirical evidence, but yeah.
I've heard the same.
Okay, interesting.
Because most often they'll go do the same job at another organization. It's the boss they're trying to get away from.
Okay, so relation with direct supervisor, what else? Good, good.
Intention to stay.
Okay, tell me a little bit about intention to
A
stay.
lot of times there'll be actual questions of if offered the same
Mhm.
salary or something somewhere else, would you choose to stay at the organization?
Okay, good.
So it kind of gets around, is the do you like the culture, or are you here for other reasons?
Okay, good. Give me a third one. Give me a third predictor. We've got intention to stay, relationship with direct supervisor. Give me another variable that might
Opportunities for promotion.
opportunity. Tell me a little bit about that one.
If people want growth in their position, the company can offer that for them or not. You know, as far as there's positions that they could promote to, or there's training programs in place to promote them.
And it's interesting because in the last few years, with unemployment fairly high, do you think some people are hanging on to the job even though there may be no opportunity for promotion just because the other options out there,
Yeah.
right, are not particularly prevalent? So now, everybody, we've got the kernel of a model for discriminant analysis. But now instead of seeing if the linear combination of the outcomes is different based on the groups, we're seeing if these groups, do you see how I've done the arrows, everybody? How well these discriminating variables best predict what? Yeah, and that gets a 0 and that gets a 1. There's your right there, there's your metric. Does everybody see that? There's your metric. Very different, isn't it? But it's similar to logistic regression. In fact, on your second take home, you're going to run discriminant analysis and a logistic regression on the same research question just to see if there's any differences. You're going to run like your own little simulation to see if those two are very different or kind of similar.
And for the underneath where it says use stepwise method, what situations would you use that option at all, or
Not
if
for
we
this
don't use
class.
stepwise?
Not for this class. However, same with regression, Zach, let's say you had 10 of these variables. 10 of these, or let's say 15, a lot of variables, and you want to find some way to maybe prune out some variables to make it a more economical model. Then stepwise would basically be, as you know, an atheoretical way to trim down the model. However, I'm very much influenced by some of the work by Bruce Thompson and other people that have, and on some of these statistical listservs that have made it clear stepwise has a lot of problems. Our squares are biased, betas are biased, you need large sample sizes, and it can be screwed.
Analysis too, still.
It all applies. In fact, that's why the journal article from Bruce Thompson is called Stepwise Methods Need Not Apply Here. So it's a major journal called Journal of Educational Psychological Measurement. It's one of the top tier journals. And years ago, Bruce Thompson said anyone using stepwise couldn't apply. Interestingly, Zach, in medical journals, they still use it quite a bit. I've seen quite a few that use stepwise methods. I have 25 lab values, because if any of you have ever had your blood taken, has anyone ever seen the report of their blood? It's a lot of measures, isn't it? Albumin, creatinine, right? I mean, tons of measures. So you put a lot in, or some of them are going to be highly correlated, so it'll kick it out for you. So I do empathize, Zach, with trying to make the model simpler, but it'd be great to not let just a statistical method dictate which should be in the model, but have expertise initially. Have expertise. So, regardless of your intentions, assumptions do matter. From Tabachnik and Fidel, transform variables if there's significant departure from homogeneity. If samples are small and unequal, and inference is the major goal, same as Manova. If the emphasis is on classification, so there's going to be a descriptive part to this analysis and a classification part. If the emphasis is on classification and dispersions are unequal, is there a chance that the variance covariance matrix for those who stay versus leave might be different? In fact, I could see where those who plan to stay, maybe there'll be less variance versus those who leave, right? Do people ever get a little bit ambivalent when they leave a company? Do they ever sometimes almost second guess themselves, right? So there may be much more variability than those. If there are, there's a couple of techniques I'm going to show you that can deal with it. One is to do separate covariance matrices, which I'll show you, and or use what's called quadratic discriminant analysis, which I'm going to show you I was able to do in another software called Stata. And you do have the handout, everybody. If samples are normal and large. Otherwise, there is what's called non-parametric classification methods if variables are non-normal and samples are small. And we'll get into logistic regression later. Logistic regression will be an alternative technique that does not necessitate meeting these assumptions. So you're going to find the same assumptions as Manova pertain to discriminant analysis. And again, on your final take-home, you're going to compare both methods. This is what's called a mathematical maximization procedure. So Mark finds that org stress and org commitment lead to optimal between-group separation for a sample of 258 Qualcomm. Whereas Maggie finds that org involvement was the only variable that led to group separation at separate. So is there a chance that you could use the same host of discriminating variables and you may get different solutions at different companies? It'd be great if you did this model and it worked at Sempra, worked at Qualcomm, worked at the San Diego Zoo and SeaWorld. It'd be great to have the same result. But sometimes could there be between organization differences, just like regression? So it maximizes it for the sample at hand, right?
Maximizes what?
The result, the fit. What is being maximized is made clear shortly. The important thing is to keep in mind that this type of procedure is employed. There's an opportunity for capitalization on chance, especially if the subjects are what, large or small. When does chance most enter the fray?
Large.
Small.
Oh.
No, because right when it's small, there's a chance that you may have gotten luck of the draw of these 20 people,
Right.
that there's more or less variance. And again, to make it really micro, does an outlier have more or less of an impact on the small sample size?
More.
Right, you got it, you got it.
So is a grouping variable always going to be one or like a male, female, yes or no, supergroup? But is it always have to be just two?
No, in fact, no, it can be as many groups as you like.
Okay.
It can be 3, 4, 5 groups. It could be management, staff, executive, and clerical. The output gets busy. The output gets really busy, Zach, which is why I'm going to keep it to 2, because first, it's how you can run the logistic regression. I'll make your life easier. Absolutely. I'm going to give you examples of when you have 3 or more groups. I had one project where we had 5 groups. 5 different cigars.
So when you coded it, you just code like 0 through 4?
1, 2, 3, 4. Yeah, you don't have to dummy code for it.
Okay.
You do not have to dummy code for it. So, the book briefly on page 246, if the DVs are denoted by Y, Y1, Y2, Y3, then discriminant analysis, the row vector of coefficients, maximizes this A, B, A, and basically where B and W are between and within sum of squares cross products. So we have B and W matrices. What does B mean again, everybody? Between, and W is? Within. You got it. You got it. And you will have a row vector of coefficients, which maximizes using a row vector of coefficients for maximization. And soon you're going to see exactly what that means. And basically what leads to best between group separation. What leads to best between group separation. So what you have, everybody, for 2 groups, just for the 2 groups example, for number of functions, the minimum number of functions is the lesser of the number of discriminating variables. So let's say for 2 groups and 5 discriminating variables, which, you know, in your mind eye, you may consider them to be, that is, predictors. And you will get a certain number of functions. So, let's say I have 5 discriminating variables and 2 groups. The lesser number will be how many functions you will get that you will interpret. And soon you're going to see what a discriminant function is. So if I have 5 variables and 2 groups, number of groups is 2 minus 1. So it's based on number of discriminating variables and G minus 1, number of groups. So 2 minus 1 is 1. So you're going to get just one function for 2 groups. For 2 groups. You get just one function, which means your life is going to be much easier to interpret. However, what if you had 6 discriminating variables? Well, what if you had 6 discriminating variables? For example, depression, anxiety, etc., and 4 groups. Middle school, high school, etc. How many functions will you get? You'll get 3.
3.
Yes. Yeah.
Number of groups minus 1.
6 and 4 minus 2. This is the lesser, right? So 3 functions tested for significant, which makes interpretation a bit interesting. When I say a bit interesting, I mean complex. So yes, Zach, and that's your question. Absolutely, you can have more than 2 groups. It just makes it a more involved interpretation, as you'll soon see. And the mathematics is going to be very similar, everybody. Very similar to Manova. Eigenvalues, Wilks lambda, boxes M for assumption, boxes M for assumption. You're going to see a lot of similarities. A lot of similarities between Manova and this. So, why don't we go ahead and get an example. So here's the syntax, everybody, for discriminant function analysis. And how do you get it? Again, as I showed you previously, you go to Analyze, Classify, Discriminant, put your grouping variable there, whatever it may be. And just so you know, everybody, when you put your grouping variable there, like what if I put in sex? You have to define what the range is. Kind of like what you had to do with the independent sample t-test. So if it's coded 0 and 1 or 1 and 2, you need to just indicate what that range is. So you have to know how the variable is coded. And then you put in all your discriminating variables under independence. And under statistics, you want to get the means, the univariate ANOVAs, the boxes M, and you get all these other matrices you may want to examine. Under classify, you may want to get all groups equal, use that, and then get these various plots. And Zach, what you're going to find is when you have 2 or more, you get this interesting thing called the Territorial Map, because it's having to plot multiple functions, which gets a little difficult to interpret. And then soon we're going to play around with the summary table when we get to classifications and leave one out. You're going to compare the result to what's called jackknifing. You're going to get into what's called a resampling technique called jackknifing. And you're going to learn exactly what that is when we get to it. And it's truly a resample technique. And we'll show you soon.
What does resampling mean?
Resampling means at the simplest level, for instance, for bootstrapping, 5, 6, 7. There's your population. I ask you how many hours, three people indicate 5 hours, 6 hours, 7 hours. I'm going to say bootstrap number 1 is 5, 5, 6. Bootstrap 2 is 6, 6, 7. Bootstrap 3 equals 5, 5, 7. Bootstrapping is a type of resampling technique where I literally take as many samples, it could be 200 or 1,000, that the computer generates, the computer goes through, with replacement. With replacement, so there can be multiple replications of that same value, and I can get a mean, standard deviation, a variance, covariance of all these. And bootstrapping is really helpful as a resampling technique in the context of maybe regression. Let's say you have only 20 people. And there's probably going to be some instability in your parameter estimates. Bootstrapping can be used sometimes because it pulls all the results together and returns to you standard errors and confidence intervals that are maybe
Based on
appropriate.
different combinations.
All these different,
It's like probability.
What do you mean by probability sampling?
Well, it's looking at combinations.
Okay, all of these together.
Replacement.
Any types of combinations and with replacement and pulls all of them together. So it's called a resampling technique. So it's computer. You need the computer. Sometimes they call them computer-intensive methodologies. Bootstrapping is used actually in one software you're going to learn at the end of the semester called AMOS for structured equation modeling. It actually has a bootstrap option, which can be used for non-normality and or small sample sizes. Now, it's not a panacea for small samples. SPSS does now have a bootstrap module. It does have a bootstrap module for all the statistics.
Yeah, I saw that.
And it'll show how much bias there is. And actually, the confidence intervals are interesting. They're actually called credibility intervals instead of confidence intervals. So here being said, jackknifing is going to be another one. Jackknifing, it will be another type of resampling technique. But the difference with jackknifing that we'll get into later, is jackknife 1, 5, 6, 7. Jackknife 2, 5, 6, 8. Jackknife 3, 5, 7, 8. Do you see what I'm doing, everybody? I'm constantly doing all combinations, leaving one out. That's jackknife. It's leaving one person out. We'll get into that soon, everybody. Again, we'll get into that very soon. So here you see we have the outcome, which is, are you in a relationship? Yes or no. Sample size, not too bad, 87 in a relationship, 59 or not. And We put in my discriminating variables right there. Or in regression, you'd call them predictors. We're going to assume there's equal probability. It's called a prior probability of being in a relationship or not. 50-50. If you maybe know it's slightly different, maybe 60-40, you can actually set the priors. And then we're going to get all these statistics, many of which you get from a Manova. So discriminant function analysis is a wonderful technique to be able to test also for significance. As the book starts on page 247, which variables are significant. So here, first of all, here's the 6 variables: exercise, diet, health maintenance, and each of the groups in a relationship versus not. And here's the pooled sample of all 146. So first of all, similar to Manova, are the variances different? Right? Again, it's hard to eyeball, especially if you have a lot of groups and or a lot of discriminating variables. But you can test to see if the variances and or means are different. It's always good to look at that. Again, unequal sample size, 87 versus 59. Does that seem like a big difference in sample size, moderate? What's kind of just your surface impression?
It's a difference.
Moderate.
Yeah, moderate.
Not huge, but
Yeah, not huge, but yeah, moderate. Not huge. No huge problem with unequal n, though radically different, better handled by logistic regression, to be discussed. But if heterogeneous variances and unequal n cases tend to be overclassified into groups with greater dispersion. You see what you're going to find, everybody. One goal is not only to see which of these variables best predicts between group separation, but to classify them, to be able to classify them into a matrix where soon you're going to be able to find if this is the stayers and this is the leavers and this is the predicted stayers, predicted leavers. This is going to be kind of important. This is going to be kind of important. This means I've accurately classified stayers accurately. But guess what's going to also happen, everybody? Here, I don't do emoto icons, but there. Does that help you?
Oh, yeah.
There, I did my first emoto icon. So.
And it's on film.
Great. So there, is it possible to misclassify? Say some leavers are stayers, some stayers are leavers.
Yeah.
False positives or false negatives. Absolutely. And that's part of the goal also, everybody, is not only to see which of these variables best predict if you're going to stay or leave in an organization, because there may be some that are more important. But we also want to know is how well do they do in classifying? How well do they do in classifying? Again, if heterogeneous variances and unequal n cases tend to be overclassified into groups with greater dispersion. Right? Tend to be overclassified for groups with greater dispersion. Which means increase of true positives or true negatives. So, heterogeneous variances as well as multivariate normality can be a problem, everybody. They can be a problem, same as Manova. Hence why we will later explore logistic regression as a non-parametric option. Just so you know, for your own interesting information, there is an interesting statistic I found in a multivariate book by Hare called the Proportional Chance Criterion. And he actually gives a nice little statistic to see how well are we doing in classifying. He has this little statistic called p squared plus 1 minus p squared. Say 93% of one group did not get promoted. Then 93% plus 1 minus 0.93 squared is 0.8698. So you better get at least 86.98% classification for two groups as opposed to 50-50. Right, 50-50, if I just flip a coin, you're going to do 50-50. You're going to correctly classify. What he was saying is, you know what, for two groups, and let's assume 93% of one group tend not to get promoted, then you better do at least 87% correct when there's a disparity in group sample size. So do you see the problems when you have disparity in sample size? That's a nice little statistic, because 50-50, if I have 93, what this tells me, so this tells me if I have radically different n in the outcome. For example, 95% do not telecommute. Then are you impressed with 50% classification? Are you? No, I mean, just by chance, you could put all those 95% in one of those quadrants and do a heck of a lot better than 50%, right? So say you have 3 groups, and by chance you'd expect 33%. 1 divided by 3 would be 33%. There'll be 3 groups. But it could be based on a higher sample size. What if group 1, you have 10 people that work clerical, 20 that are managers, 30 that are executives. And if I go and multiply 0.17 times 10, 0.33 times 2, etc., 23.3. So 23.3 divided as a percent, divided by 60 is 38%, which means you better do at least 38% for that unequal sample size. Just shows you guys that this especially happens when I get rare events data. This is especially germane. Especially germane to rare events data. Number of kids. God, what was that project with RDS? Oh, that was the project. It's called Respiratory Distress Syndrome. Some of these kids, it's going to be very scary for the parent to get this lack of surfactant in the lungs, and they can die. They can die without that. So it's obviously a harrowing time for the parents. I was on a project at Sharp Healthcare because the main lab test was up at Irvine, so it usually took 24 hours to get the results, which, you know, can be pretty scary for a parent to wait 24 hours to know if the little infant's going to live. And they started playing around with a test at Sharp Healthcare that could get the results in about an hour. So here, do many kids have, how many people in this room have ever heard of respiratory distress syndrome? Has anyone ever heard of RDS? It's a rare event, which means if I have a database of 8,000 kids, you might have 10 of them that have it. And sometimes that may be your outcome, yes or no, RDS. And that's why you can take into account that, you know what, 50-50 classification is not very good, because I could easily do 95% just by putting them all in one cell. What you see then is part of the output, which corresponds to page 247, is you get a significance test. You get a significance test for each of the discriminating variables. Exercise, diet, health maintenance. How do I know it's comparing the groups? Look at the degree of freedom. 2 minus 1 is what? 1. Are any of these significant?
No.
No. Again, it's part of the database we're working with. But above is the same as univariate F as you would get in Manova, everybody. It's exactly the same that you would get from Manova. It's exactly the same, the groups on this. So now it's just showing you the quality of the group means. None of them are significant. This can be one of your first insights into if any of the discriminating variables are going to do well. This will give you an insight in a problematic solution or any of the variables manifesting between group differences. Right? So as above, none of them are, so I already have a red flag that not all is going to be well. I already have a red flag, you guys, that we may not end up doing such a great job of classifying because none of them are significant.
This has nothing to do with prediction. Right?
Actually, to
So I
some
wanted
degree,
to
well,
say
yeah,
that
because
it's not gonna
it is
predict
good.
well.
You are going to be taking actually a linear combination of these to predict, so to speak, between group separation.
So you do want those to be significant?
You would love them to be.
Yeah.
Okay.
Absolutely, Zach. So you would love them. So you would prefer all, or at least some of them, are significant. Absolutely, Zach.
Now, significance is still going to be affected by group sample size, right?
All that type of stuff, absolutely.
Algorithm.
All that stuff,
Because
absolutely.
I'm running out my data right now and it's significant, but it,
Collinearity, all that type of stuff is still, collinearity pertains, all that. So here, do you see the 0.955 for exercise, everybody? Does everybody see the p-value 0.95? Look if I run a one-way ANOVA. 0.955. So it's the same.
But it's significant.
Really? 0.955 is
Oh,
significant?
sorry, I was looking at the F.
Okay. Right. There you go. So, Wilks test. Wilks test, everybody, as the book gets into, is a function, as you know, of the determinant of within over total. So it's kind of bad stuff over total stuff. Or it's also a function of the sum of the determinant, right, of the within over between plus within, because between plus within equals total. So that's Wilks lambda, everybody, used for significance. And the F, everybody, the F is a transformation, right? The transform, note, and I will call this transformed F. So in your reports, everybody, you don't have to add the word transform. Transformed F is a function of 1 minus Wilks lambda, right? This is good old Wilks lambda. I'll put that right up here, just so you know that it's Wilks lambda, which is 1 minus lambda divided by lambda times n1 plus n2 minus p minus 1. And this is all the formula. You can see they're actually partially on page 247, everybody. That shows the formula. So what this shows me is that it's a function, the F, of my test statistic for the Manova plus sample sizes of each group minus the number of discriminating variables minus p minus 1 divided by p. Okay. So here, everybody, let me make sure I got this. No, I'm sorry, no, p is the number of groups. Okay, sometimes they reverse it. Yeah, it's the number of groups, 2 minus 1. So, p equals number of groups. P equals number of groups. So here, you actually get, everybody, you actually get what's called the pooled within groups matrices. And this is the SW, which is the inversion of the within group matrix. So we've got 2 variance covariance matrices for each of the groups, and this pools together with the within group matrices. As you recall, on the diagonal is the variance, on the off diagonal is the covariance. And to standardize it, creates a correlation matrix. There's, right, the 1.0 on the diagonal, and here's the correlations. So now you pool them together, and you get at the correlation matrix and or the variance covariance, which serves as for the unit of analysis. Can you see you probably would not want to do this by hand? Because if you recall, inversion means not only calculating determinant, then doing all these co-minors, cofactors, and dividing by the determinant for each value. You would not want to do this by hand. So you have what's called a sum of squares of cross products for the within, which is basically this variance covariance matrix times the degrees of freedom. So you average these separate correlation matrices for all groups and then compute the pool. So you take all these variance covariance matrices for just 2 groups, and it's used to get at the loadings for the purpose of description. So one part is classification, the other part is description. Description is to see which of the variables predicts the outcome, so to speak, and you get a regression coefficient or a loading. So here's the variance covariance matrix for each group. Now sometimes this can tell you if things are radically disparate. You can sometimes look at the variances, which again are on the diagonal, and the covariances, and see if there's any radical differences. If you want to take that type of micro-analysis, you can start seeing if some things are appreciably different, which will give you some insight into between group differences on the variance covariance matrix. And here's boxes M, everybody. Bless you. Bless you.
Thank you.
And there's good old boxes M. Here you see, you get the log of the determinant for each group, right? Remember, you get a logarithm of the determinant for each group based on the variance covariance matrix. And look what it even indicates here. The natural logarithms of determinants are those of the group covariance matrices. So again, you see matrix algebra come up, and then it pools within groups. It pools this negative 3.21, takes into account both groups. And why doesn't it just average them? Why do you think? It's a good question. Why do you think negative 3.214 does not equal mean of negative 3.023 plus negative 3.887?
Because of the sample sizes.
You got it. Different sample. So in other words, guess what? If they were equal sample size, it'd be the same. Does everybody remember there was 59 and 87? So that's why the average of this, which you should think would be about 3.4 is 3.2. It's because unequal sample size. You got it. Okay, everybody, here's boxes in, which took the log of the determinant for each of the groups from the full sample, right? Took the determinant for the full sample that basically summed up the log of the determinant for each of the groups, and we got a P of 0.43 for the homogeneity variance covariance matrix. Happy or sad?
Happy.
Does everybody see that it's not significant? Which means, for now, we can say that the variance covariance matrices for those who are in a relationship versus not are the same. Remember, though, it is sensitive to the departure of normality. And that's, again, when you may want to use logistic regression. And again, when n is large, you may have an increased probability of significance. So Zach asked earlier if some of this stuff still pertains. Larger sample sizes, et cetera, and power, absolutely. It all still pertains. If I have 1,000 people, you may have significance and may not look so bad. So it does pertain. If it is significant, everybody, as to be discussed, you can try transformations. But again, I'm always reluctant to transform one or two variables from a set of variables if they all have coherent, understandable scales. But it can help. Or you can use separate variance covariance matrices, which you can do in SPSS. And I'm going to show you how to use separate variance covariance matrices. Or you can use the quadratic discriminant function, which I'm going to show you in Stata. Or use non-parametric methods, such as logistic regression. All of those, if the variance covariance matrices are not equal. The latter will especially make sense, everybody. Logistic regression, if you have a categorical variable. What if you want to capture managers versus executives versus staff? How many dummy-coded variables do you have to create for 3 groups? 2. Is it going to be, are the combination of the variables going to be normally distributed when you have a categorical in a mix? No, it's not going to be multivariate normal. So that's why you're going to soon find logistic regression can be a very flexible alternative to discriminant analysis, especially in the event. So we can see above that Wilks lambda of 0.978 is pretty close to 1.0, isn't it? Which means it's mainly what? Good stuff or bad stuff that's contributing to between group separation. You got it. Right? Which means we failed to reject the null that this discriminant function helped lead to between group differences. Would we be happy or sad with that? Happy or sad? Sad. Because we want this to be significant. Our function did not significantly lead to between group separation. And what was already a hint things were not going to go well?
When we ran the discriminant analysis?
Well, this all was
Well,
running.
when we first looked at,
The 6 ANOVAs.
yeah,
Remember that? Remember the Wilks from each one? Were any of them significant? Right, so already we know, none of these variables are going to do a good job of discriminating those who are in a relationship versus those who are not.
and if we were to report this, we would say there's not a significant Wilks lambda, which tells us that
That the discriminating variables did not significantly result in between group separation, so to speak, or predicting that outcome. So, thinking about good old chi-square, n minus 1, total sample size, p is number of variables, and k is number of groups, p plus k, 2, logarithm, 1 plus eigenvalue is 3.09. You can get a chi-square statistic with all this nasty stuff. I didn't show the full drawn-out formula, but here you have the eigenvalue, 3.09, where p equals number of variables, k number of groups, and then you can test it for significance, given the degrees of freedom. And as you may recall, using good old 0.05, 3.84 is the critical value for chi-square for 1 degree of freedom, 5.9, etc. And we can see above that for degrees of freedom of 6, see we have 6 degrees of freedom? Do you see that chi-square, everybody? It becomes a chi-square statistic. Because chi-square is also related to the f. Chi-square is actually the f is actually a ratio of chi-square between, chi-square within. And we can see that with the chi-square at 3.09, 6 degrees of freedom, you would need a 12.59 to have significance. We don't got that. We have 3.09, which means we reject or fail to reject. Given that 3.09 is not bigger than 12.59, fail to reject. There you go. And it's back down to a chi-square statistic. And I'm going to stop here. Then we can get into classification and more in-depth interpretation of discriminant function analysis.
Can you show us how to interpret that, what is it called? The territorial map?
No, absolutely next time.
Okay.
Yeah. I'll get into all the more interpretation next lecture. I want to get into that later because that's when you have more than 2 functions. And I'll be honest, half the time I can't make sense of that map. Half the time I look at it and it makes my mind fuzzy. You guys have a wonderful, wonderful week. Your homework will be due for next week, as you know, and we're right on schedule. And I would like us to start on Chapter 8. Chapter 8 is pretty quickie, everybody, on factorial analysis of variance. It's stuff you've already had, but gets into some subjects unique to Manova. So we will get into Chapter 8 next week. We'll definitely be able to start lecturing on it. So be prepared for that. Have a wonderful week, and we'll see you next time.